You ready? Okay. So the first one, I just want you to see, so often these things get misconstrued. Number 1 versus number 2, okay? Number 1, you're multiplying fractions. Number 2, you're adding fractions. What is the difference? What do you do differently when multiplying fractions versus adding fractions? Isaiah?
Adding, you need like the same denominator.
Yeah, if you're going to add fractions, you have to have a common denominator. Do you need a common denominator to multiply fractions? No. So when you multiply this, what do you get? 16 over xy. Okay, so multiplying fractions, don't get a common denominator. You don't need it. Adding fractions, you need to have a common denominator. So if we're going to add these right now, what is your common denominator? xy. Okay, so if I need xy to be my common denominator, what am I going to multiply my left side, my 8 over x by? Not y. Y over y. Who's this guy? He looks important. So y over y will be on the left, right? You're multiplying by 1, okay? What do you multiply by on the right? X over x. Okay, so work that out. 8y plus 2x all over that x times y denominator. And if you call it 2x plus 8y, I actually like that a little better, but you don't have to rearrange it. It's fine if you leave it like this. I just like to put them in alphabetical order because I'm a nerd like that. What?
Can you pull out 2 or you don't need to do?
You could pull out a 2. You don't have to because there's nothing that's going to reduce from it. So if you want to pull out a 2, sure. It would be this. It's not a bad idea to pull out the 2 just in case there is something that could reduce, but I guess my brain figures that out before I pull it out. So, but yes, you could pull out a 2. Okay. Number 3. Simplify the sum or difference and reduce if you can. Okay. What do we have to do? Common denominator. Okay, so what is a common denominator with these two things? 10xy squared. Got that? Okay, if that's our common denominator, then what am I multiplying the left side by? 2, just 2, right? 2 over 2. Multiplying by 1, but 2 over 2. What am I multiplying the right side by? 5 over 5 and y, right? This is a y squared. This is just a y, so we need another y. So 5y over 5y. Okay, so now we simplify. And again, you can just do this in one step if you want. I know my denominator is 10xy squared, okay? Now simplify your numerator. 2 times 6 is 12 plus what? 15y. Is there anything that can reduce here? No. If you wanted to pull out a 3 up top, you would have 4 plus 5y over 10xy squared. I'm okay with that answer, and I'm just fine with that answer too. The risk of leaving it like this is that you don't realize that maybe there was, what if this was a 2 that we pulled out? The 2 and the 10 you could reduce. So just, I like this better as a final answer, but you do have to kind of think through, could I take something out that would reduce? Okay, so you can give me either one as your final answer. I'll take both. Okay, number 4. What do you do first here? What? Star method or difference of squares for the first one, right? X squared minus 25. Right. Is going to look like that. Okay, so this goes away, and we treat it as x plus 5 times x minus 5. This one you're going to do star method for. So what can you multiply to get 5 that you can add to get 6? 5 and 1. So x plus 5 times x plus 1. So this is gone. Okay. What do you do next? We're adding fractions. You need what? A common denominator. So my common denominator is going to be x plus 5 times x minus 5 times x plus 1, right? That will be my common denominator. We need a little bit of everything that we have. So what do I need to multiply on the left? X plus 1 over x plus 1, okay? On the right?
X minus 5.
Yeah, x minus 5 over x minus 5. Okay, so now I can distribute that. This is going to be 4x, plus 4, plus, now you be careful if this is a minus here, right? That minus has to get distributed to everything. Because it's a plus, you don't really have to worry so much about it. So plus 6x minus 30.
Wait, if it was a minus sign in the middle, how would that change?
Then you're kind of treating this like a -6, essentially, right? You're distributing the negative to both things also. Yeah, I think I have one like that on here. I'll show you. Yeah. Okay, so from here, now we just simplify again. 4x plus 6x is 10x. 4 minus 30 is a -26. And then it's over x plus 5 times x minus 5 times x plus 1, okay? If something is factorable there, you're welcome to take it out. This is a fine final answer because there is nothing else that can simplify if you factor something out. But you could technically factor a 2 out of this, and you would get 5x minus 13 over x plus 5 times x minus 5 times x plus 1. Okay, either one of those is great for me because there's nothing that you can get rid of there. Questions on that? Okay. Number 5. What do you do first? GCF, which in the denominator here is going to be 5. So you're left with y plus 4. Down here it's going to be a 2, and you're left with y plus 4. What are you multiplying the left side by? 2 over 2. Yeah, 2 over 2. The right side? 5 over 5. Okay, so that's going to give us a common denominator of 10 times y plus 4. Okay, if you want to just make that your common denominator right away, you're welcome to do that. You don't have to. So now we're going to distribute that too. So 4y plus 2, distribute. Now here's the minus. Okay, 5 times 3y is 15y, so it's minus 15y. 5 times -4 is -20, but it's minus a -20, so it's really what? Plus 20. Okay, so yeah, if you're going to rewrite it, just make sure you write it minus and then parentheses around this, distribute it, and then you can distribute the 5. However you want to think about that is fine. 4y minus 15y, that's a -11y. 2 plus 20 is plus 22 over 10 times y plus 4. Okay. If you, again, want to pull out an 11 or a -11, if you will, I'm fine if you leave it at this point, or even if you call that 10y plus 40, that's fine. Or if you want to pull out a -11, you'd be left with y minus 22 over 10 times y plus 4. There's nothing you can simplify there. So either one of these is fine. Okay. Yeah. Okay, so here's what I would do then. I would do, instead of making it a common denominator right away, I would rewrite it separately because I think that maybe is a little clearer. So let's say, that's not what I'm trying to do. I would go 4y plus 2 over 10 times y plus 4 minus 15y rather minus 20 over 10 times y plus 4. Okay, and then from here, think about what you're doing. You're doing 4y plus 2 minus this whole thing. And that will be over 10 times y plus 4. Right? Now distribute that negative sign. So it's minus 15y minus a negative 20. Yeah, treat this like there's a negative 1 out in front, if you will, and distribute that negative 1. Does that make sense? Okay. Okay, number 6. What do you do? Factor out a 2, right? So you're left with x plus 1. What is your common denominator then? 2 times x plus 1. So you don't have to do anything to this left side. That's going to stay put because you already have your common denominator there. What do you have to multiply on the right side? 2 over 2. Okay. So you have 7x minus 9 minus, okay, now think of it this way. This is 6x, but I'm going to keep that in parentheses because I'm subtracting this whole thing, right? So distribute that 2, distribute the 2 again. So it looks like this, okay? Now you can distribute that negative to both things. Or maybe, if it makes more sense to you, maybe you want to try it this way. Instead of putting that 2 off to the right side, put it here. Right? Put the 2 over 2 there and treat this like a negative 2. That'll distribute the negative for you too. You could do it that way also. That's all going to be over 2 times x plus 1. So now simplify. 7x minus 6x is just x. Negative 9 minus a negative 10 is negative 9 plus 10. So that's x plus 1. And that's over 2 times x plus 1. What's your answer? 1/2, right? You can slash that away. Those are common factors. 1 over 2 is all you would be left with. Okay. You good? Yeah? All right. Flip it over. You don't have to flip it over. I have to flip it over. Oh, yeah.
Why is it turning to 1/2? Because you cross out the 1.
So x plus 1 over x plus 1 is 1, right? It's not 0. You're not like, when you 1 out something, that's equal to 1. So if you have a denominator of 2, there has to be that 1 left on top. Okay, what do you do with number 7? Cross multiply. Put it over 1. You get 4 equals, I'm just going to distribute right away, 5x plus 15. Take away the 15. You get 5x equals negative 11 and divide by 5. You can just leave that as negative 11 over 5 if you want, or if you prefer, negative 2.2 is fine also. Please box your answers, by the way. It's really helpful. Yeah.
I'm just confused as to like, how come for some of these you're writing them like using parentheses and like this one you just like, I guess like.
Whenever it's a fraction equal to a fraction, that's a proportion, right? And the way we solve proportions is we cross multiply them. So there's no, well, I guess you could do parentheses here. Hi. Okay, thank you. So you could put parentheses here, right? You could do 5 times x plus 3. I just did that in my head. Is that what you're asking?
Yeah.
Yeah, that's totally fine. 5x plus 15. I just distributed in my head.
I'm just wondering, like, what the difference is, like, versus, like, some of the other problems we did previous.
Right, so notice this one has an equal sign, right? We're setting two ratios equal to each other. This one, we're simplifying. We're not solving. There's no x to solve for. We're just simplifying what we have here. So you can't cross multiply when there's no equal sign in between. If it's equals, cross multiply. If it's plus or minus, you just have to simplify as far as you can go. Okay? Does that make sense? Am I answering your question? Amara? How come I didn't on this one? You could, if you want to subtract the 4 here, then you would get 11, but then you'd have to subtract the 5x to the other side, so negative 5x equals 11, and then you would divide by negative 5, and you would still get the same answer. So if you like it that way better, that's fine. You can do that. Okay, number 8. What do you do here? A fraction equal to a fraction, cross multiply, okay? So this is going to be 2x minus 3 times 1, you don't need to write, equals 3 times 5 minus 2x, okay? So it's 2x minus 3 equals 15 minus 6x. I'm going to add the 3 and add the 6x. So you get 8x equals 18. Divide by 8. Again, if you like the ratio, you can leave it as a ratio. 18 over 8 would be 9/4. Or if you like the decimal version, that would be 2 1/4, 2.25. Either one of those is great. Okay. Number 9. Okay, so can you cross multiply this? No. If there is a plus or minus and an equal sign, you can't cross multiply. There's too much information there. So instead, what do we do? Find the least. Was that blinking for you, or was that just me? Find the least common denominator, which would be what right now? 4x, and multiply everything by it. Okay, so multiply by 4x. Not 4x over 4x, right? Once it's an equation, we don't need that. Well, there's times where we need it. We're just trying to get rid of those denominators right now, so we multiply by the LCD in the numerators, okay? So multiply everything by 4x, and you get 4x squared over 4 minus, now this, 12x over x equals 4x over 4. Okay, now simplify. 4 over 4 is 1, so you have x squared minus x over x is going to give us just a 12 there, and 4 over 4 is going to give us an x. What do you do? Move the x over. So it's x squared minus x minus 12 equals 0. And now you just factor that. What can you multiply to get a negative 12 that you can add to get a negative 1? You get a negative 4, a positive 3. So x minus 4 times x plus 3 equals 0. So x will equal what? 4 and negative 3. When you get two answers like that, you should really check, do they both work? So if you plug in a 4, you get 4 over 4 minus 3 over 4 equals 1 over 4. That's true. If you plug in a negative 3, negative 3/4 minus 3 over negative 3 equals 1/4, right? So this is really plus a positive. So negative 3/4 plus 1 is going to give you a positive 1/4. So they both check out. Good to check though. All right, number 10. what do?
You do the difference of squares for x squared.
Yeah, difference of squares, x plus 1 times x minus 1 is going to replace this. And then what do we have to multiply by?
X squared, or x plus 1, x minus 1.
Right, x plus 1, x minus 1. Remember, this is where we don't want to distribute right away. So I'm going to multiply all of these things. X plus 1 times x minus 1 over x plus 1 times x minus 1 equals, now go here, it's going to look exactly the same, x plus 1 times x minus 1 on top, but we just have the x plus 1 on bottom, plus, now it's a 3 times x plus 1 times x minus 1 over x minus 1 on bottom, okay? And now we simplify. So it's going to be all of this cancels, or 1's out. That equals what? 1, right? Something over itself is 1. X plus 1 over x plus 1, so that's x minus 1. X minus 1 over x minus 1, so you can distribute this, 3x plus 3. And now simplify that. X plus 3x is 4x. Negative 1 plus 3 is a positive 2. Take away the 2. So negative 1 equals 4x, and then divide by 4. So x is a negative 1/4. Where did I lose you?
Right after you wrote like the thing in orange right under.
This?
Yeah. Can you go through?
Do you see how I got this, or it's this?
Yeah, I say you got it.
Okay, so once I have that, then I did x plus 3x is 4x. Negative 1 plus 3 is a positive 2. So 4x plus 2 equals 1. Then take away the 2, and then divide by the 4. Okay? Okay, last one, and then we need to get a move on. This says, using a small pipe, a tank can be filled in 30 minutes. If the water is pumped through a large pipe, it will only take 20 minutes. How long will it take if both pipes are used at the same time? So small pipe, large pipe, together, and separate. Oh, I'm writing that backwards. I don't want to confuse you. Let's go separate first. Separate and together. Okay, so separately, the small pipe is 30. The large pipe is 20. What's together? The unknown, the x. Okay, so we're going to say together over separate, x over 30 would be the small pipe. Together over separate, x over 20 is the large pipe, equals what? 1. One complete job. What are we going to multiply everything by? 60 would work. 60 is a common denominator there that we can use. So we're going to say 60x over 30 plus 60x over 20 equals 60. Simplify that. 60 over 30 is 2x. 60x over 20 is 3x. So 5x equals 60. Divide by 5. 60 divided by 5 is 12 what? Minutes. Yes, sir. You're just looking for a small number that, the smallest number, that 30 and 20 will both go into. You could multiply the 30 and 20 and multiply everything by 600. And you'll still get the right answer. You're just going to start with really big numbers. But 30 times 2 is 60. 20 times 3 is 60. So 60 is our least common denominator. Okay?